Good morning, class. Our lesson for today is laws of mathematical expectation and variance. The first law. If A is a constant, then the expected value of A is A. The variance of A is 0. The standard deviation of A is 0. In other words, the variance and standard deviation of any constant is 0. Law number 2, if x is a discrete random variable and the constant are a and b, then the expected value of ax plus or minus b is equivalent to aex plus or minus b, while the variance of ax plus minus b is the same as a squared variance of x. And the standard deviation of ax plus minus b is the positive value of a multiplied by the standard deviation of x. Okay, notice that variance of b, a constant, is 0 and the standard deviation of b is 0. Okay. Law number 3, if we have x and y, two independent random variables, and a and b are constant, then the expected value of ax plus minus by is a multiplied by ax plus minus bay. Similarly, the variance of ax plus minus by is just a squared variance of x plus minus b squared variance of y. And the standard deviation of ax plus minus by is the square root a squared variance x plus minus b squared variance y. Okay, law number 4, if fx and gx are function of the random variable x, then the expected value of f of x plus minus gx is the same as the expected value of fx plus minus the expected value of gx. Law number 5, if we have n independent random variables, x1, x2 until xn, where it is taken from a variable x. So x1, x2, and xn have identical probability distribution. Then we can state that the expected value of x1 is the same as the expected value of x2, is the same as the expected value of x3, and is the same as until the expected value of xn. Okay, since they are taken from the random variable x, so it has the same value of ex. Now, the variance x1 is also the same as variance x2, is the same as variance x3 until the variance of xn. Hence, it's also the same as variance of x because all these n independent variables are taken from x. So they must have all the same value. But the expected value of x1 plus x2 plus x3 until xn, since we have n independent variables, is the same as n multiplied by the expected value of x, which is also the expected value of nx. But for variance of x1 plus x2 plus x3 until xn is just n multiplied by variance of x. Okay, why is it that variance of nx is not the same as variance of x1 plus x2 plus x3 until xn? Okay, if you were to look at law number 2, variance of nx is n squared variance x. So clearly the values are not the same. Okay, let's look at the first example, how to apply the laws. Okay, notice that the first task is quite simple. You have done this in the previous lesson, finding the expected value of x. Hence, you need to find the expected value of 2x minus 1 and the expected value of 3x plus 2. Okay, please recall the formula for the expected value of x is the sum of the variable x multiplied by its probability. So you multiply each value of x with its probability. You add up, you have 0.3. So now you can apply the laws of the expectation. If you have e to x minus 1, the law states that it's just aex minus b. So applying the law is 2ex minus 1. Substitute the value of ex 0.3. So you have negative 0.4. Similarly, part C, e3x plus 2 is just 3ex plus 2. Okay, substitute the value of ex, so you have 2.9. So this is how the law is being applied. Second example, we want to look at how the law of variance is applied. We have random variable x that takes the value negative 101 with probabilities 1 over 4, 1 over 2, 1 over 4. So part A, straightforward, you can do on your own. Part B, expected value of 2x plus 1. I already shown earlier how to apply the law of mathematical expectation. And variance of 2x plus 1. Part C, the expected value of 2 minus 3x and variance 2 minus 3x. Okay, the first part, using the same formula, sum of x multiplied by its probability to get the expected value of x. So the value is 0, meaning that the mean is 0. To get variance of x, you need to find the expected value of x squared using again the formula sum of x squared multiplied by its probability. So you have half. So your variance of x is just ex squared minus the mean squared. Substitute the two values, you have half. The first one is, remember the law. If we have e2x plus 1, so it must be 2ex plus 1. So our expected value of x is 0, substitute, we have 1. But the variance of 2x plus 1 using the law is, the law states a squared variance x, so we have 2 squared variance x, 4 times 1 over 2, so we have 2. Okay, so you see now how the law make the calculation simple. See, e2 minus 3x is just 2 minus 3ex. Substitute, you have 2. And the variance of 2 minus 3x is just minus 3 squared variance x. So you have 9 multiplied by half. You have 4.5. Okay. Example 3. You are given two independent variables, x and y, with their probability distributions. So you need to find the expected value of x plus y and the variance of x plus y. So first you need to find the expected value of x and the expected value of y. You need to find the variance of x and the variance of y. So find first the expected value of x, which is 0.4. The expected value of y, which is 1.1. So the expected value of x plus y, applying the law number 3, yeah? the law number 3 says that it's just EX plus EY. So you have 0.4 plus 1.1, 1.5. Okay. Part B, you need to find EX squared first in order to get the variance. So the variance of X is EX squared minus the mean squared, which is 0.44. Then to get the variance of Y, you need to find EY squared, which is 1.7. And then the variance of Y is EY squared minus EY squared. EY squared minus EY the whole thing squared. Okay. In other words, 1.7 minus the mean squared, so you have 0.49. So applying the law of variance X plus Y, we have variance of X plus variance of Y, because your constant A is 1, constant B is 1. Okay. So 1 squared is 1. You don't have to write the value 1 in front of variance X and 1 in front of variance Y. So you add up, you have 0.93. Okay, this is applying the law number 3. Okay, now example 4. You have a discrete random variable X. Again, you look at the table, the probability distribution table. Notice that the values are X. The values of X are very, very large. 2025, 2050, 2075. Okay. So you can apply the coding formula to make your calculation simpler. So here your coding formula is given. So what is it? Y is equivalent to X minus 2050 over 25. So that is called a coding formula. The coding formula is used when the values of X are very large. In other words, we are reducing the values of X to a smaller value. So you need to construct a new probability distribution in terms of Y. So from there, you can find the expected value of Y, the variance of Y, and find the expected value of X and the variance of X. So the first task is to convert X in terms of Y. So how do you do that? Using the coding formula given, you just substitute the value of X. So you have Y equal 2025 minus 2050 over 25. So your Y is negative 1. When X is 2050, you substitute your X, you have Y equals 0. When X is 2075, you substitute the value of X, you have Y equal 1. Hence, the new probability distribution in terms of Y is given below. Okay. When Y is negative 1, the probability is 0.3. When Y is 0, the probability is 0.2. When Y is 1, the probability is 0.5. So notice that the values of the probabilities remain the same. What we have done was just that we have reduced the large value of X into a smaller value using the coding formula. Okay. So from here, you can find EY using the formula of mathematical expectation. So EY is just 0.2, and then to get the variance of Y, you need to find EY squared, which is 0.8. So the variance of Y is EY squared minus the mean squared. So you have 0.76. Okay, straightforward. Now, how to get the mathematical expectation of X and the variance of X? So are you going to use the formula sum of X multiplied by its probabilities? Yes, you can do so, but your calculation will be tedious because the value of x are large. So there's another simpler method, that is using the law of mean and variance. Okay, here I need to convert x in terms of y. So how do I get x to be 25y plus 2050? Remember the coding formula? So you rearrange. Now x become your subject matter. So your x is 25y plus 2050. So applying the law, okay, it's just 25ay plus 2050. So the expected value of x is 2055. So how the laws has simplified our calculation. And the variance of x using the law is just 25 squared variance of y. So you have 475. Okay, the last example, we have a discrete random variable x. The first two tasks are quite simple, so you can do on your own. But part C, you have x1 and x2. They are two independent discrete random variables taken from x. So since they are independent and taken from x, so clearly the value of ex1 is the same as the value of ex2 because they have identical probability distribution. So can you find ex1 plus x2, the variance of x1 plus x2? So here are the solutions. Part A, the expected value of x, straightforward, sum of x multiplied by its probability. So you have 11 over 5. And then to get variance of x, you find ex squared. So variance of x is 27 over 5 minus the mean squared. You have 14 over 25. Okay. Part B, applying the law of mathematical expectation. E2x is the same as 2ex. So 2 multiplied by 11 over 5, 22 over 5. And the variance of 2x is just 2 squared variance x. So you have 56 over 25. Now part C. ex1 plus x2. Okay, using the law just now is the same as ex1 plus ex2. And they have the same value because x1 and x2 are taken from x. But you can use also this law. ex1 plus x2 is the same as e2x, which is the same as 2ex. So 2 multiplied by 11 over 5, we have 22 over 5. And applying the law for variance x1 plus x2 is variance x1 plus variance x2. Okay, variance x1 is the same as variance x2 because they are two independent discrete random variables taken from x, so they must have the same value of variance of x. So the answer is 28 over 25. Or we can use this formula. Variance x1 plus x2 is 2 variance of x, which is 28 over 25. So they have the same values. However, variance of x1 plus x2 is not the same as variance of 2x. Okay, let's show the evidence. Variance 2x using the law is just 2 squared variance x. And we have 56 over 25. Okay, remember this class. Variance 2x is not the same as variance x1 and x2. Okay, class. So that's all for today. So you can try to do the question in task 2 given in your Google Classroom. Okay, happy solving!